In this video, we're going to look at the angle of elevation and depression, define what those two terms are, and look at some examples that have applications for the angle of elevation and depression. So first, let's start with the definition of an angle of elevation. It is defined by looking up to an object. The angle of elevation is formed by the observer's line of sight and a horizontal line. So an illustration that we have here for the angle of elevation is, here's our person, and their angle of elevation is with the line of sight going up. So therefore this angle here with the horizontal line, the base of that triangle, would be called the angle of elevation. So let's try an example using some angle of elevations in the trigonometry. So let's draw, label a diagram, and then solve for the missing part. We're going to round our answers to the nearest tenth. Our example here has Casey sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. If Casey is 6 feet tall, how far is he standing from the base of that lighthouse? Well, let's get some illustrations here. Be creative. Here's our 84-foot tall lighthouse, and there's Casey standing there. With that line of sight, we've got an angle of elevation, the bottom angle of our triangle here is 58 degrees, but we notice that Casey is 6 feet tall, so we're taking 6 feet away from the 84 feet that is in the included in the lighthouse. So we take the 84, subtract the 6 feet. That means the height of this triangle from our line of sight is going to be 78 feet. And then the real question is, how far is he standing from the lighthouse? So we put a variable down at the base of this triangle. And let's look at the relationship with our angle and our sides. Here's our angle. 78 is opposite. X would be considered the adjacent. So that tells us let's use tangent to solve for x. And setting up our trig ratio, we have tangent of 58 degrees is our opposite over adjacent, so 78 over x. We can multiply both sides by x and then divide by the tangent, but we've learned in our previous lessons that we can just switch the x and the tangent. So x would be equal to 78 over the tangent of 58, or x is 48.7 feet. So Casey is standing 48.7 feet from the lighthouse, given these ratios and an angle of 58 degrees for its angle of elevation. All right, let's take another look at an example. Leah's mom is standing at the bottom of a slide at the playground, waiting for Leah to slide down. If the angle of elevation from the bottom of the slide to the top of the slide is 46 degrees, and the slide has a vertical height of 9 feet, find the length of that slide. So again, we're going to do another illustration here. Here's our slide, and you'll see within that slide I have a right triangle drawn, so we can label some of the pieces that we do know. First, we have our angle of elevation of 46 degrees. Next, we have the vertical height of the slide, which is 9 feet. And our question is, what's the length of the slide? So that would be the hypotenuse of this triangle. So now that we have our sides drawn and we have our angle, we look at the relationship of the sides to the angle. Here is our angle. 9 is considered opposite. And we have our hypotenuse of x. So we're going to use sine to solve this trig ratio. So our sine of our angle, 46 degrees, would equal 9 over x. Again, we can switch the x and the sine and then type into our calculator 9 divided by the sine of 46, which will give us 12.5 feet, is the approximate length of the slide. Well, we can also use the inverse trig functions to find an angle of elevation or an angle of depression later on. So here we have an example that says, a dog is standing 5 feet from the base of a tree, looking up at a cat that's climbed 16 feet to the tree. What is the angle of elevation from this point that the dog is standing on the ground to the cat? So we go to our illustration. We have our tree drawn, and we're going to use a right triangle here. We know that the angle of elevation is what we're trying to find. So actually, let me backtrack on that. We know that the dog is 5 feet from the base of the tree. We also know that this cat is 16 vertical feet up in the air. What we don't know is that angle, the angle of elevation. But we can use those inverse trig functions to solve for this variable. And we also know that here's my angle. 16 is opposite. 5 is adjacent. So it looks like tangent is our trig ratio for this angle. And of course we use our inverse trig function. So x would be equal to the tangent inverse of 16 over 5, or in other words, x would be 72.6 degrees. So that's the angle of elevation that the dog is looking up at this cat. So this goes both ways. All right, moving on to the next type of angle we have. We have the angle of depression. What an angle of depression is when you look down to an object, then the angle of depression is formed by the observer's line of sight and a horizontal line. So an illustration of this is we got a guy sitting on a lifeguard chair. He's looking down at an angle. Our angle of depression, we extend an imaginary horizontal line. The angle that is created between that horizontal line and the line of sight would be called the angle of depression. But what I would like to refresh your memory on is let's go back to geometry class. We extensively went over the concept of parallel lines cut by a transversal, which led us into terms like alternate interior, same side angles, alternate exterior angles. And so here we're going to look at the alternate interior angles, that they're always congruent. So if you are given an angle of depression, they are congruent for the angle of elevation. So anytime you get that angle of depression, you can go ahead and put that angle down at the bottom as if it was the angle of elevation, just because of that alternate interior angle rule. So let's use this for some examples. A lifeguard sitting on a platform looking down at a swimmer in the water. If the lifeguard's line of sight is 8 feet above the ground and the angle of depression to the swimmer is 18 degrees, how far away is the swimmer from that lifeguard? We go back to our illustration. Here's our lifeguard. We know that he's 8 vertical feet above the ground. And if we extend out this imaginary horizontal line, we can use the angle of depression of 18 degrees. But since the angle of depression and elevation are congruent, we can go ahead and label the 18 degrees in the bottom of this triangle and put our variable for the distance and how far away the swimmer is from the lifeguard. Looking at our angle, we know x, 8 would be the opposite side, x would be the adjacent. We have another trig function of tangent to solve for this variable. We can switch the x and the tangent of 18 degrees, type into the calculator 8 divided by the tangent of 18, and the swimmer would be 24.6 feet away from the lifeguard. Okay, one more example that we're going to look at. We have building A, 480 feet tall. We have building B, 654 feet tall. If the angle of depression formed at the top of building B and the top of building A is 42 degrees, how far apart are those buildings? Well, let's get an illustration of here's building A. We know it's 480 feet. We have building B. We also know that that's 654 feet. We're looking for that distance between the two, the horizontal distance out of it. So we're going to draw some lines here, and I'm going to zoom in. And there's some things that we know about this here. First, we know that if we take the 480 feet away from building A, and we take that out of the height of building B, what we're left over with is this length here of 174 feet. The next thing that we know is that we have our angle of depression. We extend that horizontal line out, that is 42 degrees. And since the angle of depression is equivalent to the angle of elevation, we can put the 42 down in the triangle. The last part is, how far apart are the two buildings? We have our angle. We know that 174 is opposite. X would be adjacent. So again, tangent is a good trig function to use to solve this. So we set up our trig ratio. Tangent of 42 degrees, 174 over x. Switch the x and the tangent, and type into the calculator 174 divided by the tangent of 42, which says that our two buildings are 193.2 feet apart. So there's a short video over angle of elevation, angle of depression, and some of their applications.